Given the function, f of x equals x squared minus 2x minus 3, and g of x equals mx plus c. We are required to determine the coordinates of D, the turning point of f of x. Determine the equation of g of x. Determine the length of OQ, if PR equals 10 units. And determine for which values of k, the equation, x squared minus 2x plus k equals 0, will have real roots. The function f of x is given in standard form. Therefore, to determine the turning point of f of x, we will first determine the axis of symmetry for the function, using the equation, x equals minus b over 2a. The value of a is 1, since the coefficient of the x squared term is 1. The value of b is minus 2. Substituting these values in, the axis of symmetry for f of x is given by x equals 1. To find the turning point, substitute this value of x into f of x. The turning point of f of x is therefore the point, 1 minus 4. Next, we are required to determine the equation of g of x. To do this, we need two pieces of information, since we have two unknown variables, in m and c. These two pieces of information that we need, usually come in the form of 2 points that lie on the graph of g of x. Looking at the diagram, point B is an x-intercept of both f of x and of g of x. And point C is the y-intercept of both functions. Since we were given the equation of f of x, we can use it to determine the x-intercepts, and y-intercept, of f of x. Starting with the x-intercepts, we put y equal to 0. The x-intercepts of f of x are the points, 3, 0, and minus 1, 0. Since point B lies to the right of the origin, it has a positive x-coordinate. Therefore, the coordinates of point B are 3, 0. It follows that point A is the point, minus 1, 0. To find the y-intercept, put x equal to 0. The y-intercept of f of x is the point C, 0 minus 3. Now that we know the coordinates of points B and C, we can determine the equation of g of x. The gradient of a straight line is given by m equals y2 minus y1, all over x2 minus x1. Substituting these 2 points in, the gradient of g of x is 1. To find the value of c, we can either use the equation, y minus y1, equals m times, x minus x1, or the equation y equals mx plus c. I will use the former, as it is much quicker and easier. So, substituting the value of m, and the point 3, 0, into this equation, we get, y equals x minus 3, which is the equation of g of x. Of course, we could have also substituted point C, it really doesn't matter which point you use. Next, we are required to determine the length of OQ, if PR equals 10 units. Point P lies on the graph of f of x, and point R lies on the graph of g of x. The difference in the y values of points P and R, is 10 units. Just to clarify, points P and R have the same x-coordinate, since the line segment PR is parallel to the y-axis. Line segment PR therefore represents the difference between the y-coordinate of point P, and the y-coordinate of point R. What this means, is that we can say, PR equals f of x minus g of x. Line segment PR is therefore represented by the expression, x squared minus 3x. We were given that PR is 10 units in length, therefore, 10 equals x squared minus 3x. Solving for x, we get, x equals 5, or x equals minus 2. Since points P and R lie to the left of the origin, the x-coordinate for these points is negative. Therefore, the x-coordinate of points P, Q, and R, is minus 2. Point Q lies on line segment PR, so it has the same x-coordinate as P and R. Just to be clear, all points that lie on the line passing through points P, Q, and R, will have an x-coordinate of minus 2. Point Q lies on the x-axis, so we also know that its y-coordinate is 0. The length of OQ is therefore 2 units. Note that a length is always a positive quantity. The fact that Q's x-coordinate is minus 2, merely means that point Q lies to the left of the origin. We can verify that our solution is correct, by determining the y-coordinate of points P and R. Substituting x equals minus 2 into f of x, we get a y-coordinate of 5 for point P. P is therefore the point, minus 2 5. And substituting x equals minus 2 into g of x, we get a y-coordinate of minus 5 for point R. R is therefore the point, minus 2 minus 5. The length of PR equals the length of PQ, plus the length of QR. PQ equals 5 units, and QR equals 5 units. Therefore, PR equals 10 units, which is what we were given, therefore the solution is correct. Finally, we are required to determine for which values of k, the equation, x squared minus 2x plus k equals 0, has real roots. Since we are required to use the graph to do this, we need to make a correlation between the question and the information given. We were given the equation of f of x, which is f of x equals x squared minus 2x minus 3. Comparing the two expressions, we can deduce that k equals minus 3. Looking at the diagram, f of x has two distinct x-intercepts, which means that f of x has two real roots. If the function f of x is shifted downwards, the function will continue to have two x-intercepts, and therefore f of x will always have real roots. The turning point of f of x is the point, 1 minus 4. The distance between the turning point and the x-axis is therefore 4 units. If f of x is shifted 4 units up, then the function has only one x-intercept. Even though the function will only have one x-intercept, it will still have real roots. The value of k, when f of x is shifted up exactly 4 units, will be 1. If f of x is shifted up more than 4 units, then the function will have no x-intercepts, which means that the function will have no real roots. Therefore, for the function to always have real roots, the maximum value of k is 1. We express this as an inequality, k is less than or equal to 1. In other words, if k is any real value less than 1, or equal to 1, then f of x will always have real roots.